Ladies and gentlemen, please welcome to the stage a representative from OpenAI.
Awesome. Thanks. Hey everyone, good morning, or should I say good afternoon. My name is Mohammed Husain. I'm an engineer with OpenAI supporting the public sector team. And today I want to give a few demonstrations about ChatGPT along the theme of securing AI or securing the future with frontier AI. For today's talk, I'm mostly going to focus on our new class of reasoning models. So for folks who are not familiar, last September we released a new class of reasoning models starting with O1. And the key idea with these reasoning models is that they can work over an extended period of time, right? So if you've ever used something like ChatGPT, you type in a question, you get an answer back right away, right? It's optimized for speed. But the thesis we had with the reasoning models is, what if we extended the horizon that these models could think, right? Just like if your boss asked you to write a report on a topic, the quality of that underlying report is going to depend on how much time you're given to work on that assignment, right? So we're going to talk a little bit about the reasoning models and how we see this playing a large role in terms of analysis and all the different fields relevant to this audience. We were the first to release this new paradigm. We've seen a lot of other labs also adopt this paradigm. And really where we see reasoning models play a big role are things like logical analysis, intelligence, mathematics, science, programming. But for today, what we're going to focus on are topics relevant to this audience. So three sort of categories I'm going to cover today are sort of cyber use cases with our reasoning models, multimodality, which will be a ton of fun, and analysis, where we'll cover some agentic capabilities with ChatGPT. So that's the prelude. Two quick notes before I start. I don't trust the Wi-Fi here, so what you see here in terms of the tabs are a lot of these pre-run. So we're going to try to kick off these tasks. These reasoning models also take time to run. So instead of having us watch the model work for 20 minutes, we're going to kind of go quickly through a couple of use cases. But everything you see here today, you can try today, right? So if you see a prompt, you want to try it out, go to chatgpt.com, use the model, put in the prompt, and you can try it. And then again, procedural note: if I'm speaking too quiet, folks in the back, give me a quick signal so I know to speak up. So let's start with the first example here. ChatGPT.com. I'm on my O3 model, it's our latest reasoning model. And what I'm going to do is I'm going to ask it this simple question. I want you to decipher this message. And we have an encrypted message, right? And I think this is a great example of a problem that reasoning models can do that historical models could not really solve well, right? So in order to solve for this cipher, I haven't given it the specific type of cipher it is. So first needs to develop a hypothesis of what is this? What is this language? Is it foreign language? Is it encrypted? And if it's a cipher, what kind of cipher is it? A Caesar cipher, a Vigenère cipher, an Abhalt cipher. And once it figures out what type of cipher it is, it needs to figure out what are the specific steps I need to take to encode this. So historical models, you gave it this type of problem, you're asking it to do a lot of planning in a very short period of time. But instead, with this example, we can kind of show that the model is able to, it's given the time to work through the problem. One of the other things that's interesting about reasoning models, and if I could take a step back here, what you're looking at is the model's chain of thought. So it is a trace of everything that the model did, everything it decided to act upon, information sources. It's effectively a log of everything it did, everything it completed over the course of the task. And this is really important because historically we didn't have a lot of attribution into how the model came up with its responses. But now with this chain of thought, we can kind of decode how the model thinks about problem solving, right? So we can see, hey, I'm thinking it's a Caesar cipher, a substitution cipher, kind of alludes to it being a Vigenère cipher here. One of the other things that's kind of interesting and I think extremely exciting for this audience is the ability to call tools, right? So instead of training the model to be able to do everything, instead we took the thesis of what if we train the model to know how to use tools that are specialized, right? So if you have decryption software, if you have capabilities in-house that are really good at one thing, and we expose APIs for the LLM to call on these tools, now all of a sudden you don't need the LLM to memorize each and every fact in the world, but instead you give it the ability to orchestrate different tools, right? So that's kind of like the primer on reasoning, what you need to know. And what it's doing is just kind of working through the problem, coming up with issues, writes some code, executes the code, runs into issues, takes a different direction. See, you see here, it tries to import a library, it sees that, that one's not available. So, it's writing, taking different methods. It kind of explores, right? And so what I'm going to do now is I'm going to switch tabs, right? I'm going to show you what it came up with when I ran it an hour ago. So here we gave it the same message, right? Decipher this message. Took about 7 minutes. We see that same behavior where it's working through the problem, right? And at the end, we get the correct message, which is, welcome to California, don't forget your sunscreen. And it kind of walks through specifically how it was in Cypher. So Visionaire Cypher figures out the repeating keyword Oasis, which I didn't give it any information about and how to figure out. And it kind of answers that question. So I really like this example because it shows you if we give the model time to think, you can get some pretty interesting results. Let's do another example. So what I'm going to do is I'm going to upload a data set, and I'm going to give it this prompt. So it's going to take a few seconds to load, but here's what I'm going to say. I want you to assume the role of a cybersecurity analyst, right? I'm going to just kick off this task because it'll take a few minutes to run. I'm uploading for you a series of leaked text messages and metadata from a cyber threat actor based in Russia. So folks are familiar with the Conti leaks. It's 60,000 Telegram messages that were leaked several years back. And what I wanted to do is to use the context of the text messages to figure out and develop a dictionary that translates the covert slang and workaround terms to the plain language representation, right? So another kind of an example where the model is going to use code, and just to be clear, let me show you this data set. It's all kind of, you get your standard metadata. It's in Russian, but I think there's also some other languages represented in this data set. And, if I scroll here, you're talking 60-some thousand messages, so certainly not a trivial data set. But the same thing kind of happens where, we're giving the model time to think. We see that same behavior where it's going to use and execute code. So the quality of the data is actually very important, right? It's kind of a point that I like to say is that, garbage in, garbage out. There's a lot of value to having your data structured, and the ability for the model to write and execute code is still contingent upon, having very high quality structured data. But we'll show some examples later of how it can work on a more unstructured data. So I'm going to kind of jump to the end. I don't know if folks have seen, cooking shows where they put it in the oven, they go to commercial break, they come out, and it's ready to go. That's what I'm sort of doing here, is show you that, we put it in the oven for about 6 minutes at 425, and we get this sort of dictionary here where it calls out the code word and the literal meaning as well as some operational context, right? So these are sort of, basic use cases. We can do that. We have analysts that are trained for this kind of task. But what we're seeing here is the ability for the reasoning models to automate a lot of the heavy lifting, the initial triage, so the analysts can start focusing more on the complex reasoning, figure out, okay, based on these threat actors, who's the most important, who's talking to who's leading, where are the financing mechanisms, and so on and so forth. So that's sort of the intro, right? We talked a couple cyber use cases, talked a little bit about chain of thought, talked a little bit about tool use. I want to take 30 seconds to show kind of an interesting artifact. So if you came to Katrina Mulligan, she's head of national security at OpenAI. She gave a talk yesterday and talked about our relationship with the national labs. And the national labs are a fantastic partner because they really have the expertise to push these models to their technical limit. And we actually have this published report by Brookhaven of finding an exact solution to a model. And they specifically call out OpenAI's O3 mini high model as pivotal to solving this. And the funny thing is we don't actually serve O3 mini high. You can't access it anymore. Because it's considered a deprecated model, that we have better models. So just want to sort of illustrate how quickly it's moving and how partnering with national labs and agencies can really drive some interesting results. So that's cyber. Let's go to multimodal. which I think will be kind of cool. So I'm going to drop a file in here, and I'm going to say I want you to do a supply chain teardown on this motherboard. I want you to figure out as many subcomponents as possible, and then take it a step further. I want you to tell me where those factories are that manufacture those components, right? And then tabulate your findings. So, I'm pulling up the image, just pulled it off open web, right? A lot of different components. I actually got this one from a colleague, and it saw this really interesting behavior. So we see that same chain of thought. It's going to work through the problem. I talked a little bit about tool use, and what we see here is that the model actually uses the code to zoom in on parts of the image that it thinks are of high interest, right? So it's writing the code here, and it's trying to crop the area where certain chips are visible because it thinks that there's valuable signal there to solving the problem, right? So the ability for the model to really decompose problems, figure out what's of interest, and use all the tools at its disposal to solve the problem, that's where we see some really exciting things cooking with the large language models. So you see here, it thinks, hey, these 4 chips, these are of interest. I'm going to zoom in on that part of the image and see if I can pull out some interesting things from there. The second thing it doesn't just use code. We've talked about code, way too long. But it's also able to access other information sources. So here it says, hey, I see that there's a code on this component. Let me use web search to see if I can find corroborating information on that code. So using tools interchangeably, I don't have to instruct it to say, first do this, and then look at this data source, and then look at this collection. It knows what it has access to. It knows what those sources are valuable for, and it can figure out the rest from there. So here it's using web search to corroborate the information it's seeing on the board, and then reinvoking the code interpretation tool to figure out its next steps. So I'm going to jump ahead and show sort of what it came up with. 6 minutes, 14 seconds, creates the table, calls out the component, the OEM, the factory, and the evidence. And you can see citations scattered throughout. We'll talk a little bit about attribution later. But I think it's a really fantastic thing that these models can do, is also attribute the specific sources it used to get that information, right? Again, going back to that point, the data is going to be increasingly valuable here. We got one more example on multimodal, and this one's a fun one. So what I'm going to do is I'm going to upload an image, and I'm going to have the model guess where in the world this photo was taken. And I challenged you to try and guess before the model can where the model was taken. So we're going to give it a few seconds to load. Like I said, don't trust the Wi-Fi, but hopefully, if it doesn't load, I got to pull it. There you go. Okay, so time starts now. I want folks to shout out continent or country or whatever you think this photo was taken. Okay, we got Australia. Chile, okay. A little closer. What was that? Canada, okay. Five Eyes, yeah, maybe. Florida, okay, I got Florida over here. Are we sure it's the United States? Model is. We got Peru over here, okay. So it is the US, so shout out to Florida over here. Are we sure it's Florida?
Virginia.
Huh? Virginia, okay. 10 seconds, last guesses. Arizona. Was there a guess here? Okay, Arizona. All right, let's see. Let's see how smart you all are. So if I gave it to the model, it's going to take a couple minutes to run, but we see the chain of thought, zooming in on parts of the image, calls out, hey, low grassy sandy area, looks like the eastern US, so sorry for Argentina and Peru, but it did think South Africa for a sec. Starts to narrow it down to Florida and South Carolina, searches the web again to try and see, hey, is there anything corroborating here? And if I'm just going to jump to the end now, calls out, wild rabbit, this particular genus of rabbit, calls out the substrate, vegetation, topography, and correctly calls out that it was Merritt Island, Cape Canaveral, taken from the NASA.gov website. I love this example because it shows kind of the difference in where we are to what we can do, right? We have a lot of classifiers, we have a lot of image analysis tools, we have large ontologies of aircraft and bomber and Tu-95, but this is a whole nother class of models that doesn't have to be trained on very specific ontologies, but can leverage the rich knowledge of the world and tools at its disposal to solve these kinds of problems. So this one was kind of a mind blower when O3 came out, because none of the other models could do that one. So that's multimodal. We talked cyber, we talked multimodal. I'm going to do one more example. And so this one is talking about agents. So agents fundamentally are going to require very high quality reasoning models because it's talking about working on problems for long horizons, using tools at its disposal. So agents and reasoning are extremely intertwined concepts, right? So what I'm going to do is I'm going to use a tool here and I'm going to kick off a deep research task. And I'm going to put up this prompt, and I'm going to explain the prompt in a second. But what I'm going to do is I'm going to add some specific sources. So I wanted to use web search, but I also wanted to use my internal collection, right? So we have this new concept of connectors where you can connect ChatGPT to the information sources in your environment, right? So I also wanted to use Box, for example, or SharePoint or whatever as another information repository to generate its response, right? Let's talk about this answer. So hey, I want you to build an analytical assessment of cyber attacks on U.S. critical infrastructure. I want to understand targeted sectors, who are the key actors, what TTPs they're using, and I give it some instruction to say, hey, I also have, you got information that's OSINT, web search, but you also have just sort of this internal reporting that you should treat as more verified, right? Because I always get this question when we brief, the intelligence community, defense tech, like how does these models weigh different data sources, right? How does it weigh classified collect, finished reporting, partner reporting, OSINT? How does it weigh the validity? And I think these reasoning models can really start to get to the heart of teaching the models the tradecraft of understanding the value of different information sources. So before it goes off, it's going to ask, a series of clarifying questions, interested in critical infrastructure, yada, yada, yada. I'm going to say, use your best judgment. And it's now going to go off and work on this problem. And I probably should have explained this again. So deep research is an agent in ChatGPT. It's built on our reasoning models, and it's trained to do very long horizon research tasks. Long horizon meaning up to 20, 30, sometimes 45 minutes. So we don't get a response right away. That's trade-off, right? Everything's with trade-offs. We don't get an answer right away, but sometimes we're willing to sacrifice the quick answer for the right answer, right? That's the thesis of the reasoning model. So it's going to work over a period of time, and again, I'm going to sort of jump to the end and show you what it came up with. So it worked across 7 minutes or so. I'm going to try and refresh it to see if I can show chain of thought here. You're kind of getting a spoiler, but it's a kind of comprehensive response. Oh, that's okay. So what happens is, completed in 7 minutes, use 15 sources across 51 searches. And I'm going to kind of scroll through the response just so you can get a sense. But there's 3 things I want to call out in the response. The first is the level of comprehension, right? It's a very long response. You don't always want that kind of response for every ChatGPT question, but in some cases, if you're trying to deep dive a topic, that's very valuable. The second is the citations. So you'll see, one caveat, that I created synthetic data for this demo. So if you see stuff like secret no foreign or like TS, it's synthetic data, not real. Do not report me to your FSO. Again, it is hypothetical synthetic data. But that being said, right, these citations can tell you, hey, did you pull that from open web or did you pull that from some of the stuff in the internal repositories, right? That's the value of the assurance at inference time when you get the response. And then the third is, again, the ability for the model to trade off the different data sources. So I'm going to kind of quickly scroll through. I'm at 47 seconds. I'm just going to catch my breath for a second, and then we'll sort of wrap up. But if anyone's interested, I can send this via email, no problem at all. It's kind of long. Scrolling quickly. Like I said, very long, very comprehensive, very in-depth. And again, the thing I'm really enjoying is the ability for the model to weigh the different data sources, right? So 22 seconds left, kind of brings us to the end of the demo, right? So we talked about reasoning models, both as a standalone, then using different tools to solve that multimodal problem, then as a basis for these really powerful agents. And if I can leave you with kind of one idea or one nugget, I think there's three real ingredients to AI adoption, right? There's compute, there's talent, and then there's data. And I think that's kind of the right mental model to think about. If I'm trying to bring this into my environment, what pieces do I need to have in place, right? So that's kind of the triangle. You have the compute side where you need to have the right infrastructure. You need to have the right sort of environment because these models are heavy and it takes time to develop the infrastructure to actually be able to deploy these models. The second is data, right? So if I'm an agency right now, I'm thinking, how do I build evaluations on my data so that as these models become available, I can start testing them to figure out which model is best for my use case. I'm thinking about how do I make my servers and databases OpenAI or MCP compliant so that we can hook up these models with those data sources, right? And then the third one being talent. There's a tremendous amount of talent in the government. Some folks that are leaning really ahead and using agents and some still kind of at the early stages. And it's really important that we make sure we serve both communities, not just making sure that we give API credits to the most fast developers, but teaching those that are take a little bit more time to adopt the technology and show them what's in the art of the possible, right? So compute, data, and talent. Those are three tenets. Thank you very much for your time. Apologize for going over 60 seconds. Appreciate it. Thanks.